What's up, YouTube? So, in this lesson, we'll be talking about data and data types. In a previous lesson, we introduced a computer program as a collection of statements that performs some kind of task by manipulating data to produce a desired outcome. Data can be mainly any information on our computer, such as images, text, numbers. Considering our previous example, the Hello World example, we manipulated our data here in a way to print them out to our console. Data is stored in a memory as a sequence of ones and zeros called binary digits. A binary digit, or a bit for short, is the smallest unit of memory, and a bit can have a value of 0 or 1. Usually 8 bits are called 1 byte. The memory is organized into sequential units called addresses. We can consider them as boxes, and each box has a certain name, and inside each box we have certain data. Usually in modern systems, they are byte accessible. This means that each memory location here stores 1 byte, which is 8 bits. Okay, so because working with zeros and one is not intuitive and quite hard, we use data types to tell our compiler how to interpret this data. C++ has some built-in data types called fundamental data types. In this video, we'll be introducing some of them. Okay, let's get started. So, the first data type is called an integer. An integer is an integral type from the word integer that can represent a whole number, positive or negative, -3, 4, 5, 100. C++ mainly has 4 types, so short, int, long, and long, and the difference between these is the size. Here, C++ doesn't explicitly define the size of each, it depends on your computer, but it ensures that it has a minimum size. Usually on regular PCs, such as mine for example, an int is 4 bytes. So the difference between that is that larger integers, so for example long, can hold bigger numbers than smaller integers, such as for example short and int. What that means, let's consider 1-bit integer. So a 1-bit integer can have 2 binary values, either 0 or 1, which correspond to 0 or 1. Okay, let's say we want to store 2. We would need a larger integer. Let's assume we have a 2-bit integer. So in a 2-bit integer, we can have 4 values, 0, 1, and 10, and 1, 1. This is the 1 here, sorry. And this would mean that we would have 0, 1, 2, or 3. You can see here that now we can store bigger numbers. The same thing goes here. The larger the size, the larger the number we can store. Integers can be signed, which is the default case, or unsigned, and the difference is between both of these is the range. So assuming we have a 1 byte integer, so 8 bits, we would have 2 power 8 values that we can store, which is 256 values. For the case of signed integers, our range would be from -128 till 127. Whereas for the case of unsigned integers, we would start with 0 and then we can go up to 255. So the next data type we'll be talking about is bool. So booleans, or bool for short, are a specific type of data types which can store one of 2 values, true or false. These are useful in programming certain Boolean algebra applications, or for conditions, or for yes, no questions, true, false, facts, stuff like that. Booleans can hold only true and false, which are actually built-in keywords in C++. They are defined by the bool identifier, and in reality they are integral types. They evaluate to 0 for false and 1 for true. So considering the following program, this would output this output here. So you can see that true is evaluated as 1, whereas false is evaluated as 0. The next data type we'll be talking about is characters. So characters, or char for short, is an integral data type which is used to store characters. Actually, an integer is stored which represents this character, and this number stored is defined by ASCII. ASCII stands for the American Standard Code for Information Interchange, and it mainly maps English characters and some symbols to numbers between 0 and 127. So for example, the symbol uppercase B would have an ASCII code of 66, lowercase b would have an ASCII code of 98. The number 6 as a character, not as a number, would have the ASCII code 54. Please note that summing characters, for example number 6 and character number 4, wouldn't yield 10. It would actually yield the character which has the sum of their ASCII code. So try to avoid using numbers as characters in arithmetic operation unless you actually want to do so. And the dollar sign, for example, is 36. There are certain characters which are special, called escape sequences. We have seen one of the escape sequences before, which is the \n to create a new line. An escape sequence usually starts with a \ character. That's how a compiler knows that's an escape sequence, and then is followed by some letter or number. The table here summarizes all the escape sequences defined in C++. So considering a quick example, we have here and some escape sequences. You can see here the double quotes, a new line, we have a tab here, and then in order to actually print a \, we have to have a \ as an escape sequence, and then the \ to actually print one \, and then \n, which creates a new line, and then this would output here. You can see we have the quotes here, and then we have a new line, and then we have the tab here, and then we printed the \ here and also a new line. So while integers are good, they can do everything. We most of the time would be interested in having numbers with some fractional part, or any real number. So we would use floating point numbers. An example of a floating point number would be, for example, pi or -3.33, or any real number actually. C++ has three main floating point types. So a float, a double, and a long double. Each has a specific size. On modern architectures, the floating point are represented through the IEEE 754 binary format, which mainly defines the range of the numbers and the precision of each number. To actually make the concept of precision more clear, we have the following example. So here we define, for example, a float as a really long number, and the suffix here means that it's a float. And we define a double without a suffix. It has a fractional part, then it's automatically considered as a double. This would only print 6 digits, because usually cout has a standard precision of 6. In order to show more digits, we import this library here in order to set the precision to 16. And after printing out, you can see here at first you assume that the both values are true, but with higher precision you can see that floats aren't stored as precise as doubles. So usually we would prefer to work with doubles unless we have like limited resources or something like that. We would use floats, but we usually prefer to use doubles.